Hello, everyone. This is another technical walkthrough with EF DevOps team. We're here joined by Raphael and Philip. Gents, thank you so much for joining. For more context of everyone who is watching this, by the time this video will go live on our YouTube channel on Minify, YouTube/Minify, EF DevOps is one of the projects which is part of the Ethereum Attackathon, which is currently live or was live, but I don't know what's the time by when you're watching this. Ethereum Attackathon is the largest attackathon on Minify currently, with rewards of up to $1.5 million. KYC is required, and many more interesting stuff, and most importantly, many projects participating. So today, we're diving into EF DevOps functionalities, protocol, and any type of testing and everything else. I'm going to mute myself at this point of time. As you all know, I'm not a technical person. So guys, take it away. Thank you so much for joining. Feel free to share your screen and everything.
Okay, thank you very much for the intro. Yeah, just so I'm Raphael and we have Philip here. We are part of the EF DevOps team. It's like a sub-team in the Ethereum Foundation. We are mainly helping on like Ethereum hard forks, like on the future upgrades. So we run a lot of like these testnets that you see currently, maybe if you're watching this later, but as right now we have like this Mekong testnet, which is a testnet for the upcoming fork running. And yeah, we are kind of responsible of coordinating, like interacting with client devs and so on. And because of that, we think that we have some tooling that could be very useful for this attackathon, which is mainly like, how do you run a local network, right? So yeah, you might have the intention of going like all in and attack mainnet, which is fine, but maybe in some cases it would be nice to reproduce what you think is a bug locally first, and for that we have tooling. And I'm just going to try to share my screen.
We don't encourage anyone to attack mainnet, just to be clear. Yeah. Don't do it. Don't listen to Raphael.
Yes, run first this thing that we are going to show you. So I'm going to try to share my screen. Okay, can you see it?
Oh, good.
Yep.
Amazing creative there, amazing graphics.
Yeah, thank you very much for the DevCon folks that have created like these arts. We kind of reuse the templating. So yeah, this is going to be about local Ethereum DevNet testing, how to run like a local network, and then also how to interact with it, and yeah, run some workflows, tests against it, and so on. Yeah, we're going to split this up in two parts. I'm going to talk about how to spin up the DevNet itself, and then Philip will talk about how to run Assertor. Assertor is a tool where you can run a certain scripts or workflows against the testnet. We use it a lot for testing. So yeah, how do you run a local DevNet? So we have this tool called Kurtosis. Kurtosis allows you to spin up like dev environments locally. It relies on Docker, for example, on your local machine. And we have developed this package that we call the Ethereum package, which allows you to configure like an Ethereum network locally. Yeah, we will also like share these slides later so that you can have easy access to these links. So the code base for this Ethereum package lives in this repo. Yeah, main dependencies that you need is locally is Docker installed and also installing Kurtosis. And yeah, running a testnet, then a local one, is as simple as running this simple one command that I'm showing in here. By default, this will just spin up, I think, one node testnet. I think it's a Geth and Lighthouse pair. But on the next slide, I will show you actually how you can configure like a proper testnet. So you want to have multiple client pairs running at the same time. So maybe, as many of you know, in Ethereum, we kind of have this client pair split into execution layer clients and consensus layer clients, as you can see here. And a participant is basically always the combination of one of these. So we see like in this YAML in here that we have a list of participants. The first example says that it's Geth and Teku, and we have 2 of them, and we can define more participants inside our network like this. So we just keep appending to this list. Additionally, there are like some services that are like nice to have. We see, for example, in here, additional services. We have a transaction spammer, which is doing exactly that. It's just generating transactions in your network. And yeah, and then we also have more tools. One interesting one is Dora, which is a block explorer, kind of. We will also show like all of these tools and how to access them. So right now, before I continue this presentation, I'm actually gonna run this configuration right now on my machine. So I'm gonna switch to the command line. So it's just doing Kurtosis run, the address to the package, and then I'm providing my custom config.yaml, which is what we have seen more or less on the presentation. So I'm going to run this. This, based on that configuration, takes around, I think it's 2 minutes from last time I've tested. Of course, this depends how many nodes you have in your network. The more nodes you have, the longer it's going to take up to spin this. So with this configuration, we can check just quickly here. So this is the file. We have, so here are 2, 4, 5, 6, 7, 8 client combos running, and the additional services. So yeah, this takes 2 minutes. And while this is spinning up, as we see, it's doing stuff. Let's go back to the presentation. If I manage to go back, there we go. Yeah, and so basically we have this configuration file where you define all of this. This is just a very simple example. There are way more options you can do. You can add additional command line arguments to each client. You can define CPU memory limits and vars, the validator counts that you want to have, and so on. If you want to know more about all these details, there's like on the main README, let me just click it. Yeah, this is on the main README of the Ethereum package. There's a whole section for configuration, which tells you exactly what you can do. Yeah, just, it's a lot. There's, it's very configurable. And there are also a lot of examples besides the one that I've just shown in our actually CI tests. So we run a lot of CI tests with different things. And here are a bunch of different configs, for example. I'm just checking some of them for you to see. But for example, this is called Nimbus All, which runs Nimbus with all the other EL clients. And we run this periodically, automatically at the CI level. Yeah. So going back here to the presentation. Okay, I just showed you the run command for Kurtosis. Sorry, just need to go back again. So when we did the run here, we saw that I provided an enclave name. I called it my testnet, and I provided it config file, right? So now we can list the enclaves. When I do that, I would expect to see like my testnet enclave there. I can inspect it. Inspecting it will show me all the client combos I'm running there and all the services and how to access them. This means like RPC endpoints, the Beacon API endpoints, anything that can be or accessed from the node level will be there. Then there are also like ways to inspect certain files. For example, to run this local devnet, there's so we had to it did it automatically. You didn't see it, but it creates like a Genesis configuration for you. So the Genesis configuration, you have to provide this to all the clients so that you know when to start the blockchain, let's say. And with these commands, you can check all of that configuration if you are curious about how it looks like. Then there's also a dump command. This is very useful for, imagine that you found a bug somewhere, or you think you found a bug, and you want to share your findings with someone, right? So this dump command will actually dump to a local directory the current state of your DevNet. And the current state here means like all the logs from the running containers and also their files that they have. And with that information, for example, client devs, most of the times are able to reproduce a certain bug that you found out. Then you can also, of course, you want to see logs. You can see logs for the whole, for all the services, or you can target a specific service. For example, on this command, I'm just showing the Dora logs, which is like the Explorer that we have, but you can also show the logs for like a specific client pair. And then, yeah, cleaning up, removing Enclave, and so on. Yeah, this is just an example of how it looks when you inspect an Enclave once it's running. I'm going to also show this very soon, like live. This is the dump I was mentioning. As you can see, it creates like, yeah, it just dumps everything it has. Then you might ask, okay, DevNet is running, but how can I interact with it? Or in a sense, what keys can I use to like send ETH around or run some tests? We do have some pre-funded accounts, so there's a list in here. Some of them are assigned to specific tools, so ideally you shouldn't use those. But as you see, this goes up to index 12. We have 21 keys. So if you use some of the ones that are at the end, it should be fine, and you shouldn't interfere with any other tooling. So you can just, yeah, pick the private key and interact. Then, yeah, so this will bring up Dora, as I've mentioned previously, which allows you to, yeah, explore around the chain. Also Blockscout, which is also an explorer, but is more focused on the execution layer side, so more on the EVM side, as we know it from Etherscan and so on. Then we also have Grafana dashboards with a lot of metrics for all the clients that are running. And yeah, now I'm actually going to switch back to the command line, and we are going to proceed with the live demo. Yeah, so this is how it looks like once Kurtosis is done with the run. It will print out, I think it also, yeah, it also, if you scroll up, it prints you out also the private keys for the pre-funded account, so you can also grab them from here if you want. And it will print out all the services that are running. For example, if I want to access Blockscout in here, I just open this URL, and I have a fully functional block explorer here. We see that we are already at block 29, for example, block 28. Well, this is going well, live demo effect. Let me just try another one, just curious to see if this one. Well, I guess some issue with Blockscout, but that's fine. Maybe once you try this will work. Then we have Assertor. I'm not going to talk too much about this because Philip has a whole section about this, and we don't actually have any tests registered right now here. We do have then, you see all these CL1 Teku Geth. So this is the Teku instance, which also exposes port 4000, which is the beacon API. So if you want to access the beacon API for that specific node, you could also like interact via here. You would, of course, have to put in here like a beacon API address. I don't know them by heart right now. I think it's V1. Well, it doesn't matter. At least, yeah, you see you have like all the client pairs here. And now one thing that is actually quite good to visualize all of this network is Dora. So we have Dora. If we open the address for Dora, This is how it looks like. We see that we are on epoch 1, slot 37 right now. We see who proposed the slot. We also can verify if we actually have all the nodes in network that we defined in that YAML file, and we do. We can also check like peer information from the nodes into details. This is for the consensus layer clients. You also have the execution layer clients. This is actually an interesting graph, because now you might ask, wait, didn't we just have like 7 nodes and we are seeing like a lot of circles in here? And that's true, but this is Nethermind. Yeah, this is probably just a bug where Nethermind is reporting other nodes that it discovered as peers, but they are actually not part of this network. Yeah, we need to fix that. Yeah, so this is Dora. There's like a lot of information here about also the list of all validators. So this tool is very, very useful to like browse through the blockchain. And yeah, if you need more detailed transaction information, then you would go to Blockscout. And I'm now curious because I really want this to work. Nope. Anyway. Yeah, we have another important one is Grafana. So if we access Grafana, we will see some metrics. There are multiple dashboards that we have in here. An interesting one is, for example, this Ethereum metrics exporter overview. Let's say 15 minutes. The network isn't running for that long. Yeah, we can see here in general, like even the consensus specs, like chain ID and so on, and CPU usage, consensus layer node metrics, execution layer node metrics. Yeah. So if you're curious about our network performance, you just have a look in here. Then I didn't mention this, but this is also interesting. You might see this Snooper engine. So this is so the communication between the beacon node and the execution node is done via the engine API, right? And the Snooper engine is just something in between that is snooping that connection. So you can actually see live. Let's try that. Logs, yeah. So we can do Kurtosis, service logs. And I want to see the Snooper engine 3 Prism Nethermind. So this will show us actually all requests and responses happening at the engine API level for this specific node. Yeah, and yeah, so I just showed you now the logs example of the Snooper, but you can also get logs. For example, if I want to check one of the CL clients, I could check, let's say, CL6 Lighthouse Besu. So this is showing me Lighthouse logs. If I would like to now see the Besu logs for this relevant node, it would be EL6 Besu Lighthouse. Okay. So I'm looking now at the Besu logs. And what else? So yeah, let's do a dump. So if we do a dump like this, so Kurtosis Enclave dump, it dumped it here. We can actually see here the content. So yeah, for every service that is running, for example, here Teku, I can get like the logs, and it did it basically for everything that is running. Also, there are like files for Genesis generation. There's like the config here. Yeah, you can get all of that information from here. And let me just see if I forgot about anything. Logs, clean. Yeah, now once we've done whatever we wanted to do, to clean everything up, you can just do Kurtosis clean -a, and it will clean up everything. Yeah. You can also verify that this is using Docker. If you do Docker PS, right now you only see like the containers that Kurtosis is using. So there's an engine that it needs to be running, which is what the Kurtosis CLI is interacting with. If I would have done Docker PS before doing this cleanup, we would have seen way more containers. We would have seen like all the client pairs, Dora, all the explorers, and the Snoopers, everything. And I think that's mainly it from my side. And I'm going to hand over to Philip now, who's going to talk about Assertor.
Yep. Oh, let me share my screen too. One. So you should be able to see my screen now, right?
Yep.
All right. So Assertor is actually the second tool we want to show to you. It's a relatively new tool that we've been working on over the last year. And Assertor is basically used to actually do certain action on a testnet and assert the expected outcome of these actions. That ranges from simple network stability checks to more complex test scenarios, which involve specific transactions or beacon chain operations, deposits, whatever you can think about doing on the beacon chain. To do so, Assertor connects to multiple consensus and execution layer nodes to maintain a stable view of the network and runs a YAML-based test playbook that contains instructions of what Assertor should do. To monitor the execution and the results of that, Assertor provides a web UI and basically a REST API for programmatic access. I'm gonna start with how to run Assertor. The first way to run Assertor is basically really easy because it is actually already part of the Ethereum package. So you can simply enable it by adding Assertor to the additional services, as you can see on the right. And the Ethereum package basically takes care of most of the configuration. So Assertor gets started with a pre-funded wallet key and with all the consensus and execution clients in the configuration. The only thing that you have to configure here, what we've seen before on Raphael's presentation, is that you need to define a list of tests that Assertor should run. Otherwise, it's just starting up and doing nothing. As soon as Assertor starts with the Kurtosis package, you'll get the Assertor link in the Enclave Demo, as shown by Raphael before. So you can simply click on it and open the web UI. The other way to run Assertor for development purposes is directly from the repository. Simply clone the repository and run make devnet run to get a fully running in Kurtosis devnet with a local instance of Assertor running for it. That simplifies the development of new tests a lot because you can reference like local files in here, where in the previous version you always have to specify a remote link here, which is a little bit harder to develop. So if you develop no new tests, but we will show right afterwards, it's probably better to just do a make devnet run and open the Assertor UI via this localhost link. When opening the UI, you can see a nice overview of all the tests that are executed by Assertor. You can see if they succeed or not, the runtime of it, and you can actually also use the web UI to register new tests and start tests on the fly. But yeah, before we go deeper into the UI, I'm gonna tell you how to run tests or how the tests are built up with Assertor. Assertor takes a list of YAML files called test playbooks that contain a list of tasks to execute. These tests can be referenced by each other and loaded from remote locations, like from GitHub, which allows bundling of tests. So instead of providing a list of like 10 test playbooks, you can only announce one test playbook for example, all the Pectra tests, and everyone can use that. That's referencing all the other tests that we have for Pectra. The tasks within these test playbooks can range from simple shell script to the generation of complex operations, including various beacon chain operations, special transactions like deposits, and so on. I've linked a few interesting test playbooks that involve pretty much all the currently supported tasks that we have. First, we have the validator lifecycle test, which runs through various scenarios of the validator lifecycle, starting from deposits, doing BLS changes, getting slashed, doing voluntary exits, and so on and so on. Another interesting one is, for example, the Denkun opcodes test, which sends out a bunch of transactions just to test the new opcodes that were introduced by Denkan at that time. And yeah, there are actually quite many more interesting playbooks. I can only recommend using them as a blueprint when writing additional tests, as they are pretty well written. So yeah, just open one and you can see they can be pretty long. And yeah. So let's take a look at how these playbooks are actually structured. And I promise to keep that a short overview and don't go into too much details of it, because yeah, the task structure can be getting complex, especially if the tests are getting bigger. So yeah, all the test playbooks basically start with a short header that contains a unique ID, a friendly name, and some generic properties like a timeout or the default config of the test. Afterwards, there's simply a list of tasks to execute. In this example here, we can see a test playbook with 2 tasks. Each contains a task name, a title, a user-friendly title, and the configuration of that task. The tasks are then executed in the order as defined by Assertor, where the next task only starts when the current one is succeeded. So it's basically, yeah, it's pretty much comparable to how a CI pipeline works, just with more specialized types, task types for Ethereum networks. Yeah, currently Assertor supports about 35 distinct tasks, which can be divided into 3 different types of tasks. First, we have a bunch of check tasks that check for certain conditions on the network. This can be blocks with specific contents, network forks, client status, and so on. Check tasks usually keep running and wait for their specific condition till hitting a timeout or otherwise cancelled. Then we have a bunch of generate tasks that are actually generating and submitting specific operations to the network. This, as already said, includes generating deposits, BLS changes, voluntary exits, slashings, special types of transactions, including blob transactions or new set code type transactions, and so on. And yeah, the last group is basically just structural tasks that allow more advanced execution flows, including matrices or concurrent execution of tasks. Yeah, all the tasks that we support, I've also linked that here, basically contain a README underneath that describes what exactly the task does, what input parameters it supports, and how it does look by default when using it in a playbook. Yeah. So there are also some more advanced features of Assertor. For example, it allows nesting of tasks, which allows advanced things like concurrent execution, matrices, and so on. An example on here, we can see that there is a run tasks matrix task that runs that check consensus block proposals task for each element of that array. So we can basically, in that scenario, do that check consensus block proposals task for every client in the network that has a validator client to check if all these clients are working and proposing blocks. The last important bit of the playbook structure is the variable system. As in most CI pipelines, Assertor allows setting task configurations dynamically. These dynamic configurations are served as test inputs or as outputs from other tasks. It gives us a lot more flexibility. For example, in that example here, we can see that the first task here loads the specs, and the second task basically uses the specs that are loaded by the first task as an input for the wait condition. And we can even do some simple arithmetic operations in here, like adding one epoch to that number. And that's really a powerful way to chain outputs of specific tasks, the input of other tasks. Yeah, that's basically all the magic that these test playbooks contain. So I'm gonna move on how we actually use Assertor today. There are basically three scenarios which we use Assertor, or we used Assertor in the last year. First of all, we use it to trigger new operations in early DevNets, which means we provide a very simple test that just triggers new operations without checking any results. Triggering these operations, for example, for the pack for DevNets, it was consolidations requests and withdrawal requests. It's already enough to trigger consensus bugs if they don't work as expected. So we see a chain split even without checking the actual outcome of the operation. And that was heavily used by client teams to get their clients ready. And we also used it to check the client's readiness before launching the bigger public testnets, which is quite some effort to set it up. And yeah, if it breaks with the first operation, it's basically a waste of time. So we, check these clients before with simple Kurtosis testnets. The second scenario we use Assertor for is reproducing bugs. We've built several playbooks just for reproducing some specific bugs, which help client developers a lot to reproduce these issues later on. Most recent example for that is the EIP 6110 test. I've linked it here at the last link, which is basically just a test that we've added yesterday and reproduces that chain split that we currently see on the Mekong testnet. So yeah, it's a nice way to reproduce that bugs, and client teams use it a lot to check their clients if it's still vulnerable or not. And yeah, the last scenario we use Assertor for is for recurring regression testing. We've built a reusable GitHub action that includes all the logic to start a Kurtosis DevNet with Assertor in a simple GitHub workflow. The action basically starts Kurtosis testnets and monitors the Assertor API to wait for all the test execution and reports back on failures. It basically streams the logs from Assertor. So even the GitHub action fails if a Assertor action fails. And yeah, we can see this here. It's really a simple action. You spun out Kurtosis Assertor GitHub action, and it spins up a fully working Kurtosis testnet with Assertor. And yeah, we heavily use that approach to run daily tests with the latest client releases. This automated process spins up multiple devnets. In this example, we have like 10 devnets here running in parallel, and each of them run through various Assertor tests and testing if clients really still work as we expected. And that's extremely helpful for us to identify broken clients, basically. And we've already seen several client releases that got yeeted due to bugs that we found just by running these tests every day. And yeah, you can basically also take a look at that repository and take a look into the action. You can see basically all the results from every day. And you can also see that we have had some problems in the last day with it, but yeah. So yeah, I think that's everything from my side as well. Happy local testing, I would say.
Yay.
Love it. Thank you, Jens. Thank you so much. Is there anything else? Is there anything else that you decided not to include in the presentation? We still have a bit of time here. Maybe something out of interest that you want to cover, some interesting discovery, anything like that?
Yeah, I think as Philip mentioned already, we just had like this bug yesterday. It is happening on Mekong right now, and yeah, I mean, this whole tooling has been so useful for us. Just being able to, even now you find a bug, you always have the problem of, okay, how do I think I found a bug, but how do I pass this information now over to the developers so that they can fix the bug, right? How can they reproduce this? Most of the times you kind of try to provide them logs and that's it. But with having like this Kurtosis local DevNet plus like the Assertor tests, you can easily give them like the full stack so that they can also run it locally and easily reproduce it and have way more data that they need to like fix their bugs. Yeah.
That's actually what we are also doing. If you monitor the interrupt channel in the ETH R&D Discord, you can basically, if there is a bug, you can always find a Kurtosis config where we reproduce that bug easily, just for client devs to pick that up and use that for reproducing.
Yes.
Got it.
So yeah, it's worth to mention that client devs also use this. So
and actually, that's
yeah.
actually right. And even the Kurtosis GitHub action that I just shown is actually used by some client teams in their CI pipeline. So they check their clients before releasing all the tests you have to just sanity check if everything is still working as expected.
Understood. Understood. Wonderful. Then, I mean, if we don't have any other comments, I think it's a good point to wrap up. Thank you so much, Jens. I'm gonna stop the recording, and everyone who's still watching, who got to this part, good luck, or just I hope you learned a bit more after this video. So thank you so much.